A nice feature for our decision tree models is that it has a capability to do feature importance. To recap, feature importance is a way in which we can derive some sort of metric, some sort of score for all the features in our data set that tells us how important each one is, how important it is to make a prediction. If there's one feature that really drives the prediction, then it's going to have a very large feature importance score. And while the primary goal of machine learning, supervised machine learning, is to train a model to make predictions, and ideally predictions that are really close to the true answer, another thing that we need to consider is some analysis where you can see what are the most important features. By analyzing, by understanding which are the most important features, we can go ahead and use that information for perhaps additional data collection. If a certain feature is more important, then it makes sense that we spend more time to accurately measure that feature. If there's some features that are not as important, then we must ask ourselves, is it necessary to include that feature for making predictions? Perhaps it's going to streamline our data collection process. So let's explore feature importance for decision trees and how this metric is derived. For linear regression, we saw feature importance, and we saw we can take the beta coefficient. So long as we scale our data set, we can look at the beta coefficients to give us a measure of the contribution that feature has to the predictive value. Well, how can we derive feature importance for a decision tree? What do you think the model will be relying on? Let's go back to the decision-making process. Remember the decision tree, at each node, it's going to ask itself, what is a good feature to use to split my data? Let's say I'm working on classification. What's a good feature to use to best separate my classes? And it goes through, considers all possible candidates, and it takes that feature, figures out where to perform the split, and it performs a split. So if a feature that is used a lot throughout the decision-making process, in other words, a feature is going to be used to perform a node split, then the more often this feature is used, then you can argue the more important it is. And let's say feature 5 is often used to perform a node split, then that feature is rather important. That feature is going to be very important to discriminate our classes. That feature is most important to derive at our predictive value. But not only is it, we need to consider how many times a feature is used to derive a question, to derive a node split, but it's also where it's positioned in the tree. Let's go ahead and draw our decision tree. So we're going to start at the very top, the root node of our tree. So we start here. All our training observations exist there. And it's going to choose a feature to use as a node split. And it performs a split, and we divide our space into two. And then we repeat the process recursively until we reach some sort of termination criteria. Let's say at this point, at this initial split, it decides to use feature 2. So it's a feature 2. And then over here, it decides to use feature 1. And let's say here, decide to use feature 3. And then over here, decides once again to use feature 2. Let's consider this initial node split here. It decided to use feature 2. And notice at this point, it's going to have the consequence of using feature 2. There's a great amount of consequence, a great amount of effect for deciding to use feature 2 as opposed to other features. Because at this point here, this using feature 2 had the most effect, had the most influence on the structure of the tree. All our training observations lie in this node, but the deeper we grow our tree, the less amount of training points exist in the node. So here we might have used feature 1 to perform the split, but this has a consequence only from this point of the tree down. And at this point here, the influence of using feature 2 once again is only going to affect the growth of the tree, the structure of the tree, at this point down. It's not going to affect the other branches. So using a feature at the closer and closer we are to the root node, the greater impact it has on the overall structure of our tree. And you can think of as we grow deeper and deeper, we have another split here. At this point, let's say we use like feature 5, then this only has effect on a small number of points. Only has a effect at this point and any future branching off. So not only is it important to understand how many times a feature is used, but consider where it's used in the growth of the tree. Earlier on in the growing process, it's going to have a greater impact on the overall structure. So to derive feature importance, we got to consider where it's located in our tree, as well as how many times it's used. So using these two metrics, I can derive a feature importance. And for the ensemble models, gradient boosting, random forest, I can go ahead and derive a feature importance for each feature, for each tree, and just take an average across my entire forest or my entire group of trees. So let's explore using feature importance. So we're going to tune our models. We're going to use the random forest classifier. We're going to use 20 estimators. We're going to tune max depth and tune min sample split. And let's go and say verbose equal to 1. Let's fit that grid search object, and let's look at the best model. And for our resulting model, we're going to use the feature importance attribute. This will tell us the relative score. We're going to dump the results in Pandas so we can easily visualize it through a bar plot. Let's go ahead and run that. Here's the results. So this is our iris data set. And looking at our iris data set, it looks like the petal length and petal width are the two most important features. Looks like petal width is slightly important, but overall we can just make the conclusion that the dimensions of the petal, have a greater predictive ability than the sepal dimensions. So if we want to streamline our model, we can just use maybe 2 or 3 features for any future models. In this case, we just take the petal dimensions and we only have to worry about measuring dimensions for our petal.